Hello everyone, welcome to 1-9 Guiding Notes for Significant Figures from Unit 1, Properties of Matter. In this lesson, we're going to look at the guiding question, what is considered a significant digit in a number, including the different types of zeros, and how can we use this to determine the significant figures in a number. And here is the do now, and you would practice this and try and think about how many significant figures you think there are. So it is important to be honest when reporting a measurement so that it does not appear that to be a more accurate answer or measurement than the equipment used to make the measurement allows. So if you only have something that has tick marks for the ones place, recording something to the hundredths place is lying about how precise that instrument is, and that is not acceptable. We can achieve this by controlling the number of digits or significant figures used to report a measurement. By looking at a recorded measurement, we can know the precision of the instrument used to make that measurement. So all rules for determining significant figures are, all non-zero numbers are significant. So every number between 1 and 9 is considered significant. So we have 1, 2, 3 digits here. They are all non-zero, so we would say that there are 3 significant figures here. Looking at the next one, we have 1, 2, 2 significant figures. And the final one has 1, 2, 3, 4. 4 significant figures, because anything that is not zero is significant. Now with zeros, it gets tricky. If it is trapped between 2 non-zero numbers, it is always significant. So looking here, we have a trapped 0, so there is 1, 2, 3, because all trapped zeros are significant. It's like those 2 non-zero numbers are bringing significance to that 0. So this one, we see a trapped 0, so that one is significant because it is between 2 non-zero numbers, so we have a total of 4 sig figs. Looking at the last one, it is between, these are all significant because they're all between 2 non-zero numbers. So 1, 2, 3, 4, 5, well, let's recount that. I'm sorry, guys. 1, 2, 3, 4, 5, 6, because the 5 and the 9 trap all of the zeros between them, and so they are all significant. Next, leading zeros. They hold a spot and give size or magnitude to a number, but aren't actually significant. So leading zeros are never significant. So these leading zeros are not significant. So I would count 1, 2, 3 sig figs. Not significant, 1, 2, 3, 4. Neither one of these, because they're both leading, they're out in front, are significant, so I only have 1 sig fig. And finally, trailing zeros are only significant if there is a decimal point there. So looking at this, there is no decimal point, so these are not significant. They give size to the number or give it a magnitude big enough, but it is not significant in measurement, so we would say there are 3 sig figs for this one. There is a decimal place here. Notice these are the same number, just different units. This decimal place acts to kind of trap or give significance to these zeros. So I have my 3 plus the 2 zeros is 5 total sig figs. Finally, or not finally, next we have this one where we have sig figs here, and this 0 is after the decimal place and after a non-zero number. So they are both, it is significant, so I have a total of 3. Note that these ones here are leading zeros, not trailing, so they are never significant This 0 is after a decimal place, and it is a trailing 0, so it is. So we have 1, 2, 3, 4 sig figs for that number. Finally, counting numbers and conversion factors have an infinite number of significant figures. Conversion factors are defined to be a specific number, okay? So they can't have something, it can't be like wishy-washy, whatever. They are defined to be that relationship. So in this bottom one, this is a conversion factor. That is an infinite number of sig figs. It is defined to have that meaning. Same for this one. Counting numbers, you can't have partial of a pencil and it still have the same purpose and functionality as a full pencil. Like you can't just have the eraser part or the middle lead part or just the wood of the pencil. You have to have the whole pencil for it to have meaning as a pencil. So counting numbers have an infinite number of significant figures. So if I said 13 eggs, 13 is an infinite number of significant figures. So looking at this one, how many significant figures are in 3.500 liters? Well, 1, 2 for the non-zero numbers, and then our zeros are trailing. We know that for trailing zeros, if there is a decimal place, they are significant. So there is 1, so they are significant. So 1, 2 for my non-zero, and then 2 more for my zeros gives me a total of 4 sig figs. Okay, so for the we do, you are going to scan the QR code and watch it. Please note that they may call the the trapped zeros are the same as sandwich zeros. So pay attention to that. They mean the same thing. It is okay. And then if you are a foreign exchange student, notice that the comma is different than a decimal place here. This is not a decimal place. So this does not give significance to anything if it's being used as such. Okay, so don't treat a comma in these ones as a decimal place. So complete the we do's by scanning the QR code. Then complete the you do. When you've finished all of it, please answer the guiding question in your notes. And then if you have been absent or are absent, you can upload the assignment to Schoology for credit, or you can wait to turn it in when you return. Thank you.